YouTube, welcome back. You are given a sorted array called nums of distinct integers and a target value called target. The goal is to find the index of the target in nums. If the target is not found or is not present, we return the index where it would be if it were inserted to maintain the sorted array order. To solve the problem, we need to do it in O of log n. Runtime complexity, we should use like a binary search tree. And a binary search tree is basically if we have our own array, what we go and this array have like elements like 1, 2, 3, and maybe 4. And for example, we need to find the element of 3. And instead of going one by one to search it to O of n complexity, we could divide the array, okay, 3 and 4 and 1 and 2 here and 2, and by then we start looking at each one. For example, we have our middle, so we see if our middle, for example, our middle in here would be 2, for example, and we see our target is 3, and we see if 2 is less than or equal to 3, but basically 2 is less than. And since this is a sorted array, all the left side will not be equal to 3, so we only have this, and we could continue to divide them, like we have like 3 and 4, and we will find it immediately. So it's way more efficient, it's way more easier for the code, and it's not that hard to understand. We will do it in the code here. So we create 2 pointers, one called left, which will equals 0, and one will call right, which will equals nums dot length minus 1. I guess is length, right? Oh no. Okay, and I create a while loop here. While we should make it while left less than or equal to right, and I would say okay. We say let. No, it's not typing. Yeah, okay. So first we start to find a middle, and the middle will be like the main character that, or the main index we try to find our target with. So the let the mid will equals math.floor to be like left plus right divided by 2, and we'll have its if statement here if nums of mid equals the target. If that was the case, that means we are fine, we found it, so we return mid or return the index. Else if mid is less than nums of mid is less than target, that means the target is in the right half. Okay, if it's less than if nums.mid is less than target, that means we should be in the right half. So we move the left to the right, so left will equals mid plus 1. Else, I guess we have only one thing left, which if the mid nums.mid is bigger than target, that means basically the target is in the left half. So we remove right to the left. Right will equals mid minus 1. And we continue. If we found the mid, if we find nums.mid, we return it. But what we'll do if we didn't find it all, let's go outside of the loop, and I guess we should return left, and that's it. Like if target is not found, left is the insertion point, and that's it. It's a pretty simple one. So to understand it here, we use 2 pointers. We have left and right, and left starting from the beginning of the array and right starting from the end. We calculate the middle index, like the mid For the binary search tree, we have mid equals math.floor, left plus 1 plus right divided by 2. We compares nums of mid with the target. If nums of mid equals to target, we return mid. If nums of mid is less than target, we move the left pointer to mid plus 1. If nums of mid is greater than target, we move the right pointer to mid minus 1. Um, if the loop ends without finding the target, left will be the position where target should be inserted to maintain the array sorted. And I will highly recommend you to walk through examples to make sure that my things my what I'm saying is right. And let's just try to submit the code and see how well we are doing. Okay, we are beating a lot of people. Okay, that's okay. That's good. That's good. That's good. Okay, so that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss any video, and see you guys in future problems.